Hey guys, this is Mr. C, and in this video we're going to be looking at some geometric sequences. And so the first slide I've got here for you is what a geometric sequence looks like. You have a sub n, which defines the sequence, and it's equal to a sub 1, which is the first term, times r, which we're going to call the common ratio, to the n minus 1. All right, so that's what the structure looks like. We're going to look at some common problems, and then I'm going to explain a little bit about what's going on here for these different sequences. So like arithmetic sequences, we added or subtracted each time from the first term. Well, this time we're going to multiply a number, a common number, every time to get a new sequence. And so that's going to be the whole concept here, is multiplying instead of adding. All right, so our first problem, it says Kelly drops a tennis ball from a height of 12 feet. After each bounce, the ball returns to a maximum height that is 2/3 of the previous height. Write a geometric sequence to model the situation. All right, so you start out with a sub n equals, then you have your first term. Well, it starts at 12 feet. And so we're going to put 12 here. And now we have the common ratio. After each bounce, the ball returns to a maximum height that is 2/3 of the previous height. So what's happening is it's losing 1/3 of its height each time. And so if it returns to the 2/3 of the previous height, if we want to know the height, let's put a 2/3 in here. And then we're going to put an n minus 1 right there. Now let's see what happens here. So what happens is the first term is 12. Because after nothing happens, it's 12 feet in the air. After the second term, we're taking 2/3 of 12. So if we take 12 and we multiply it by 2/3, so let's do that over here. 12 times 2/3. Okay, we're going to get 12 times 2 is 24, divided by 3 is 8. And so we get 8 right here for our second term. So is that the height at the end of the first bounce? Yes. So it went from 12 to 8, and we could do that one more. So if we take 8 and multiply that times 2/3, 8 times 2 is 16 divided by 3. So this time, this can't cancel out with the 3 at all. And so we just have to put 16 over 3 for this term. Okay, so what's happening is we're just multiplying each one by 2/3 every time. And so to find the common ratio, which is 2/3 here, then you just take one term, divide it by the previous, and then you're going to get 2/3 each and every time. And so that's basically how you build the sequence from this right here, the a sub n, in the explicit form right there. All right, let's take a look at another one. So this one says a petri dish contains 4,000 bacteria. Every hour, the number of bacteria in the dish doubles. Write a geometric sequence to model the situation. So we have a sub n equals, okay, so what's our first term? What's there at the start? And there's 4,000 bacteria right at the start. And it says it doubles every hour, right? Okay, so if it doubles, then we're going to multiply by 2 each hour. We're going to put an n minus 1 here. So here's an interesting thing. Why is it n minus 1? Well, we saw an n minus 1 with arithmetic that got rid of that term for arithmetic, so you get your initial value back. For this one, if the first term is 1 for n, 1 minus 1 is 0, 2 to the 0 is 1, and then we get our 4,000 back for our first term. So we do need it to be n minus 1 for this problem right there. And that would be it. And you could sit there and you could, write out all of the terms if you want to, or the first 5 or 6. But this right here would be the explicit rule that gets you all of the terms of that sequence. Okay, the value of an investment depreciates at a rate of 5% each year. If the investment was initially valued at $20,000, write a geometric sequence to model the situation. All right, so we have a sub n equals, and it looks like we have 20,000 as our initial value. All right, now, what's going to go in parentheses for our common ratio? Well, it depreciates at a rate of 5%. So if we take 5% off of 100%, that would be 95%. And 95% as a decimal is 0.95. So we put our n minus 1 up there so that when n is 1, you get all of this is equal to 1, and you get 20,000 back. So this right here would be our sequence for that problem. And so that's all we had to do. Okay, let's take a look at this one. The half-life of a medication is the time it takes for the half of the dosage of medication to lose its effectiveness. A patient is given 300 milligrams of medication with a half-life of 1 day. Write a geometric sequence to model the situation. All right, so we got A sub n is equal to, and then we have our first term, which would be 300 milligrams. Okay, so after 1 day, half of that is going to be inactivated, or it's not going to be available for effectiveness, so that would just be 150 left. So what happens is every day it loses half of its effectiveness every single day. So that means our common ratio would be 1/2, which is very common in a half-life problem. Put your n-1 up there, and then we're done. All right, let's see, we got another one here. This one says the population of a growing city of 150,000 residents is found to be increasing at a rate of 4% per year. Write a geometric sequence to model the situation. So let's do A sub n is equal to, looks like we have 150,000 right from the start. It's increasing at a rate of 4% every year. So if we start at 100 and add 4 to it, that would be 104%. And that would be 1.04 as a decimal. And then we're going to put an n-1 up there. And then there's our sequence that's going to represent that situation. All right, so a couple different problems here. Let's look at this one. Find the missing term of the geometric sequence below. So we have 6, 12, blank, 48. All right, let's see if we can find the common ratio. The common ratio, you take any term and divide by the previous. We can't really do that here. We can't do it here, but we can do it here. So 12 divided by 6 is 2. And what that means is, if it's geometric, we're multiplying by 2 each time. So to get the next term, we just multiply by 2. 6, 12. 12 times 2 is 24. 24 times 2 is 48. And so we're just basically multiplying by 2 each time. And that's how geometric sequences work. And so 24 would be the number we would put into the blank there. Okay, we got another one here. You're going to get fractions quite a bit. So we have 3/2, 9/4, blank, 81/16. Let's go ahead and find the common ratio. And so this time we need to take 9/4 divided by 3/2. All right, so what we have here is we really have 9/4 times, and then you flip this one, right? Because it's keep, change, flip. So 2/3 will go here, wouldn't it? Okay, so 9/4 times 2/3, you can cancel some stuff out. 1, 2, 1, 3. And so it looks like it's 3 times 1, which is 3, over 2 times 1, which is 2. So apparently the common ratio is 3/2. Okay, so 3 times 3 is 9, 2 times 2 is 4. So 3/2 times another 3/2 is 9/4. So we need to do that one more time. 9 times 3 is 27. 4 times 2 is 8. One more time. 27 times 3, 81. 8 times 2, 16. So now I know I have the correct number that's in the space right there. All right. Here's another one. Okay, so this time we have 2/3, 8/9, 32/27. Again, we don't know what the R value is, so let's find the common ratio. So we're going to take 8/9, divide that by 2/3. So that's going to be 8/9 times the reciprocal, keep, change, flip, 3/2. And that would be, let's cancel some stuff out here. 1, 3, 1, 4. So it looks like it's 4/3. 4/3 is our common ratio. And so now we need 32 times 4, and that's going to give us 128. And 27 times 3 would be 81. And that should give us our new next term. So that problem's done. All right, so here in this one, we have a couple terms missing. we have the first term missing and we have the third term missing. So here's your first term, second term, third term, fourth term. Now I know there's going to be people that are going to be able to look at that and say, well, I know how to do it. I can look at it and tell what two numbers. But that won't get you any credit on a test or quiz because they're going to expect some work done. So, or some kind of a process or a solution method. So let's take a look at this. A sub 2, the second term, is 16, right? Well, what that means is if you know that our sequence looks like a sub n is equal to a sub 1 times r to the n minus 1, right? Okay, that's 16 right there. So what we really have is 16 is equal to the first term, which we don't know, a sub 1 times, and we don't know the common ratio either yet. Our n value for this problem is 2. 2 minus 1 is 1. And so we get 16 is equal to a sub 1 times r. The fourth term, a sub 4, is 64. Again, we have a sub n is equal to a sub 1 times r to the n minus 1. I don't know what these two guys are either, but I do know that the fourth term is 64. So I have 64 for this one equals a sub 1 times r to the 4 minus 1, which is 3. All right, now I have two equations and I have two unknowns. That's a system of equations that are exponential. So here's one thing I can do. I can take 64 equals a sub 1 times r cubed, and I can divide that. I know this is going to be weird, but trust me, I've done it in physics enough times to know that it is something you can definitely do. 16 is equal to a sub 1 times r to the first power. We're going to divide those two equations. 64 divided by 16 is 4 equals, the a sub 1's cancel out, and 3 take away 1 is 2. So what happens is you have 4 is equal to r squared. Well, there's two values that are going to make that true. You could have r is equal to 2, or you could have r is equal to negative 2. So there are two different numbers that would make that true, right? So we're going to have to basically we could deal with both of them, but let's go ahead and say that r is the positive one. Let's just take that one. R is 2. Okay, so we need to find out this one right here. What times 2 is 16? Because your common ratio has to be 2. So let's put an 8 right there. Let me use a different color. We're going to put an 8 right there. Okay, so we got 8 times 2 is 16. 16 times 2 is 32, right? So let's put a 32 here. Okay, so are those two terms that would work? Definitely. All right, what else would work? Well, if you consider r is equal to negative 2, you could have put negative 8 there and negative 32 here, and those would also work. So alternatively, there are two different answers for this that I would mark correct. Either 8 and 32 or negative 8 and negative 32. Any combination of these, though, would not be correct because they either both have to be positive or they both have to be negative for this problem. But either one will work. All right, let's take a look at this one. The first term of a geometric sequence is 3 and the common ratio is 2. Find the fifth term of the sequence. All right, well, let's take a look. A sub n is equal to, first term is 3, common ratio is 2, 2 to the n minus 1. It says to find the fifth term. So we want a sub 5. So we're going to plug a 5 in there for n. So we want 3 times 2 to the 5 minus 1. All right, 3 times 2 to the 4th. So we have 3 times 2 to the 4th is 16. 3 times 16 is 48. And so the fifth term is going to be 48. You could do it this way, or you could have done it like this. First term 3, right? Common ratio is 2, so 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. And there it is right there. So, which way is better? Well, I'm going to tell you this way is better. The reason why is because if that n value, if they said find the 10th term or the 15th term, then you're going to have a lot of this going on. And that might not be a 3, or that might not be a 2. This could be fractions. So you definitely want to learn this way right here, because this is going to be easier when these two numbers and that one can change. All right, so let's try this one. The first term of a geometric sequence is 3/4, and the common ratio is 1/2. Ooh, this is going to be fun. Find the 7th term of the sequence. All right, a sub n is equal to, first term is 3/4, got it. Okay, common ratio is 1/2, got it. N minus 1. Okay, so we want a to the 7, or not a to the 7, a sub 7. Okay, so we got 3/4 times 1/2, 7 minus 1. That's going to be 3/4, 1/2 to the 7 minus 1 is 6. And here we go, 3/4. All right, 1/2 to the 6th power. 1 to the 6th is 1, 2 to the 6th is 64. So 1 over 64. So now all we have to do is multiply those together. And we're going to get 3 times 1 is 3 over 4 times 64 is 256. And that right there is your 7th term of the sequence. All right, guys, hope this helps. Remember to like and share and subscribe to my channel if you're not already. And we'll see you guys later. Bye.